Hi everyone. We're going to get into our chapter 8 on variables and expressions. This is a bit of a longer chapter, so I'm going to be skipping through a couple of the exercises and asking you to just do them on your own and then check the solution. But again, if there's any questions about why a solution is the way it is, you can stop by help hours, post on the discussion boards. We are here to help. Before we dive into it, I wanted to take a moment to reflect with you on how far you've come. This is the last chapter for week 2 of our course, and yes, it is an accelerated course, but remember back to 2 weeks ago, many of you had never coded before, never made a Python program, and now think of all the exercises in the lectures you've done, in the labs, in assignment 1. You've written programs. You've come a really, really long way at learning how to communicate with the computer through programming. There might still be some challenges with that, and I promise you there will probably always be challenges with that. I've been doing this for many, many years, and I still have days where I write code and I get errors, and that's okay. You learn how to deal with it, right? I find that I like to take an approach of problem solving with it, where I know the computer is just dumb and it just can't understand me, and I have to go and put my detective hat on and figure out what's going on. Why isn't it understanding me the way I am? So maybe some of that perspective can help you feel a little bit better about the programs you're writing, and really do give yourself a pat on the back for how far you've come. You should be very proud of yourself. You've accomplished a lot in 2 weeks. It's a lot of information, and you're doing really, really well. Okay? Now, variables and expressions we've already been using in this course. We have seen variables like mouse x and mouse y, and as well as variable names that we've given as part of our functions as input, where we told the computer, we know we want a value here when the program is running. We just don't know what that value is right now, but you'll be able to figure it out then, and it has. But most of those times when we're using things like mouse x and mouse y, were variables that were defined by processing. We can also define our own variables and tell the computer, hey, I don't know what this value is right now, but I'm going to give you some instructions and you'll be able to figure it out. One way that I like to think about variables is kind of like files in a folders, files and folders within a filing cabinet. I have a filing cabinet just down here to my right. It contains a whole bunch of papers that I would really like to get rid of, but I have to keep hold of for one reason or another. I can just keep them in my filing cabinet. The folders have labels on them, and until I need to access one of them, I don't have to really worry about it. But say I want to do something with my car insurance, I can say, okay, I'll go into my file system. I'm going to look through all my folders until I find the one that says car insurance, pull it out, and deal with all that data that's in it in the moment. Variables are the exact same thing, but just for the computer. It's a way for it to store data for us in a named fashion so that it knows where to go and find that data. When we are making variables, we will want to give names to them. The textbook goes over all sorts of rules for how we can make variable names. There are things like they can't start with an underscore, but they can contain underscores. They can't start with a number, but they contain numbers. And of course, the golden rule of computer science, no spaces. I think I told y'all in one of the very first videos that computer scientists hate spaces. And we do. And one of the ways that we hate spaces is in variable names or function names. We do not like them. So instead we would use something like an underscore instead of a space, or something called camel case. Camel case is when we would do things like this and just capitalize the second word as we squish them together. If we wanted to make this a variable and we wanted to assign it a value, all we would need to do is use that fancy little equal sign, which does not mean equals in Python. It means assignment. And we can just give it a value. And so that means whenever the computer is told to use this variable dog name, it's going to go find what data's in it and use it there. So later on, we can do something like print, and it will print the value that's stored in that variable to our console, which in this case is Ryder. One of the biggest missteps, I think, of the Python language is that they didn't make the assignment symbol this. It would have made a lot more sense if that was the assignment symbol. In some other language, it is for variables. Wow, can I type today? No. Oh my goodness. Some other languages use this, and it makes a lot more sense. It's saying we're taking this data and we are putting it in this variable. That's what the equal sign means in Python. It's just we have to kind of retrain our brain to think about it that way while we're working in Python. So we'll see lots of examples for that later on. But the equal sign in Python does not mean equals. We use something else to represent equals, and we hate spaces. That's the main takeaways I want you to get so far. So exercise 1, you can go through this yourself, figure out which ones are valid variable names, which ones are invalid, and check your answers with the solutions that we have posted on the course website. For exercise 2, we're going to use some variables to write a processing program with the following behavior. So when the user clicks the mouse, a white circle will appear at the mouse's location. If the user clicks somewhere else, a white circle will appear at that location and the old circle disappears. When the user presses the B key, it'll turn the circle black, but it won't move. So there's a lot of different things that we need to do in this question. So we're going to just start with the first bit, that when a user clicks a mouse, a white circle will appear at that location, and then we'll continue to add to it. So make sure you open up your processing and make sure that it's in Python. And then we're going to get started adding all of the information that we'll need here. Since it's going to be an interactive program, we know we're going to need those fancy functions called setup and draw. Whoops, too many tabs. So our setup is what gets called, remember, at the very beginning of our program once to set up our canvas. And our draw is what gets called a whole bunch of times as the program is running. So let's just give our canvas a size to start things out with. Classic 300 by 300. And we'll put the background as, what color is this? Pop quiz, where the points don't matter. Now, just to make sure I have things set up correctly, I'm just going to add in a return in our draw. So telling the computer to effectively ignore that draw function for now. And I'm going to run it to make sure I get no errors and I get my 300 by 300 canvas. I think I said fill will set the background, but it's not going to set the background, is it? We would have to use the background command for that if we really wanted to change that, and then it would switch it to white. We can just leave the background as it is and leave that fill up here to say, hey, any shapes that I start drawing, I want them to be white. And we know we want them to be white because that's what the exercise specification tells us. We want to be drawing white circles at the mouse's location. So that is going to happen when the user clicks a mouse. We know that if we're doing something on an event, we're going to have to use one of those other functions that gets called when an event occurs. In this case, because it's a mouse click, we're going to use that mouse clicked function, which gets called anytime the user presses down and releases on the mouse. What we want to do is draw a circle. So previously, we might have done things like, okay, ellipse. Can I spell? Not today. Mouse X. Mouse Y. And sure, 30/30. I don't know if it specifies the size, so we'll just go with that for now. And if I run this, I can click and add all sorts of circles all over my canvas. So we know that this is kind of working as expected, what we would have seen in the past. But what we need to address now is the second part of the question. If the user clicks somewhere else, we'll only get a circle at that new location and the old circle is going to disappear. Well, we could add in our background command and effectively clear every time the mouse is clicked. We've done something like that before. But what we want to do now is start using that model view controller design that we talked about in the textbook, where if we have information that we want our program to keep track of, we're going to store that in variables that would be the model of our program. The view would only be updated in the draw, so all of this ellipse, etc. would only be in the draw, and the mouse clicked or the key pressed would only update our model. So effectively we have 3 different components that are all working together. It's a very common design for different types of projects, and you'll see it a lot in second year as well, where we set up what information do we need to keep track of. Okay, let's continuously draw our picture based on that information of the model. And if we want to change our model, we'll do it through those event functions. So we're going to modify all of this a little bit here and add in first our model. So instead of just using mouse X and mouse Y down here, we want to use variables. And in order for us to use variables that would be associated with the model part of our program, we need to set up what we call global variables. So those are variables that we could use anywhere we wanted in our program. And these are going to be exactly what we would need to keep track of. So in this case, we need to keep track of our X coordinate and our Y coordinate. And those are going to change whenever the user clicks a different place. So we're going to set up 2 variables, and we're going to call them X and Y. When you're setting up these variables, you need to assign them an initial value. And for this case, let's just put them somewhere that would be off the canvas so that the user wouldn't see them at all. They're not going to see a circle until we click somewhere on the canvas. We can leave our setup as our size here and our fill. That's totally fine. And then what we want to do is move out this draw part, this shape part, and we don't need this background anymore. That was for a different part of the explanation, but we're going to move this shape part into our draw function. So things like mouse clicked, things like key pressed should not be drawing shapes. Only our draw function should. So I'm going to copy this out, and I'm going to put it here. Okay, tab it over to make sure that it's in line properly. And before we were using mouse X and mouse Y. Now if I just put a return here, and if I try to run this now, we get this chained circle, right? Which is not what we want. That has nothing to do with if I'm clicking something. That gives no different behavior. That's completely not what the question is asking for. So to modify that, instead of using our mouse X and our mouse Y here, let's use our global variables of X and Y to draw that ellipse. Now to tell the computer we want to use our global variables, we have to very, very clearly do that. So we're going to use that keyword global and then say X. And again, global and Y. That tells the computer that inside of our draw function, we need to go find that global X variable and that global Y variable and figure out whatever values are in there, and it will plop them automatically into wherever we want to use them. And now we want to use those as X and Y coordinates in ellipse instead of the mouse X and mouse Y. So if we run this, it's going to look like a whole lot of is happening, but that's because we set up our initial values to be, for X and Y to be -100 and -100. So that's going to be way out here that's not on the canvas. But we're not getting any circles that are following our mouse, so we are making a step in the right direction here. What we need to do now is get that clicking functionality enabled. And so when the mouse is clicked, we need to update this X and Y global variable with the mouse X and mouse Y value. So all we need to do in order to do that is tell the computer, okay, inside of our mouse clicked function, we want to use the global X and Y variables. So we're going to use those global keywords. And then we're going to assign them new values. So we type the variable name, we type our assignment operator, which is that equal sign, and then we give it a new value, which in this case is another variable. We say we don't know what the value is going to be when the user clicks it, but we can use the information stored in this other variable that's already available in processing and just give it to our global variable. And we can do the same thing for Y, where we will use the value of mouse Y. Okay, and now if I run this, and if I click, 3, 2, 1, woohoo, we did it! And we can click and click and click and click and get new circles at all these different X and Y locations. Okay, so we're getting there. We're kind of closer to where we wanted to be, but we only want one circle on the canvas at a time. When we click somewhere else, or the user clicks somewhere else, the old circle needs to disappear. So because we're modifying our view, that means we're going to have to add something into our draw function. And what we're going to do there is we're going to use the background command to effectively clear the canvas every time draw is called, and then it will redraw the circle at X and Y. Because draw is being called continuously as our program is run, it will feel effectively instantaneous for the user, that when they click, they see that circle pop up in a new area. Now, the gray color that is the background, it might be hard to know exactly what it is. We can try some different values out. I'm pretty sure it's 210 because that's what they have in the solution slides, and I think we probably tested out to figure out what it is. So we have our model of our global X and Y variables. We're using them in our draw function to actually draw the circle. We're clearing it every single time, so if the circle moves, we won't see our old circles. And in our mouse clicked, we're updating our model, or this would be our controller, to change the values of X and Y. So if we run this now, and we click, beautiful, click again, and it moves, and we don't have circles that are just persistent on our canvas. So that is got through the first bullet point there of functionality that we wanted. Now, for our next bullet point, we want a new action to happen when the user presses the B key. So when this happens, we want to turn the circle black, but it doesn't want to move. So effectively, we need to think about, okay, the X and Y will stay the same, but we'll need to do something else here. And there's a couple of different ways that we can modify this. So we know we're going to need to use that second function called mouse clicked that will be triggered whenever, oh, not mouse clicked, sorry, key pressed, that will be triggered whenever the user presses a key on the keyboard, right? Any time, it will always be pressed. And inside of that, we only want something to happen if it's the B key. So what we need to do is use a control statement in order to check to see if the user pressed the B key. If they didn't press the B key, we don't need to do anything. So we're going to use that if statement that we were talked about in chapter 1, and then we're going to give it a condition. So what this condition is it's going to be some sort of expression that will evaluate to either being true or false. So it's checking to see, did this thing happen that we wanted to happen? If it did, we're going to do something specific. If it didn't, we're not going to worry about it right now. Now, Python or processing has a special variable called key. Just like mouse X and mouse Y, it's predefined by processing. And what it does is it keeps track of the key that the user pressed on their keyboard. So anytime key press is called, that variable key is going to have a new value associated with it. If we wanted to just take a look at how this worked, let's just do a quick print command and put the value of the key or the variable key inside of that. So anytime key is pressed, we're going to display that to our console. So this will show you kind of how that works. So still it's the same program. We can click and make circles in different places, right? Great. But now I'm going to press keys on my keyboard and they will be displayed to the console. H, I, C, M, P, T, 1, 4, 0. And because this is an interactive program, it's continuously running, it's continuously waiting for user feedback. That just keeps on printing and printing and printing anytime that I press a key. So we can use that information to say, hey, let's check to see what key did the user press. If it's B, we're going to change the color of our circle to black. Okay, so let me stop this here, close that. So again, we'll use that if statement, and then we want our condition. So we're going to use that variable key, and what we're going to do is we're going to check to see if the value stored inside of key is equal to the string B. It might be very tempting to use this as our equal sign. Is that our equal sign? No. I just hear resounding no's coming from all over the world, from all of the students in CMPT 140. No, no, no. That is our assignment symbol. So because we use it for variable assignment, we can't use it to check or evaluate expressions to see if something is containing or storing some other value that we're looking for or equal to. Being the geniuses we are as computer scientists, we thought, oh, no worries, we can solve this. We've already used the equal symbol for assignment. So when we want to check to see if something is equal, we'll just add a second equal symbols after that. And that will be used to tell the computer, hey, when you see two equal signs back to back, check to see if these two values are equal. So if the value in a variable is equal to some literal that we specify, or maybe if the value in this variable is equal to the value in that variable, whatever. We can do all sorts of cool things with that, and we'll talk about it later. In this case, we're checking to see if the value stored in key is equal to the string B. If it is, we're going to change the color of that circle. It's going to stay in the same spot, but we will just change the color. So one way we can do that is just call the fill command and say, okay, next time you draw something, we're going to just use this color here. If you wanted to, you could also make a second global variable or third global variable. That's Canadian color won't be a keyword, and you can give it a default value. Since it was white at the beginning, we'll do a default value of 255. Now when we're using grayscale, you can just put in the literal number here, and then whenever you wanted to use it down here, you could just say fill color. If you did this exactly, it won't work because we have to also tell the draw function that we would like to use that global variable we just made called color, and that will work perfectly fine. And same with down here, we can just, instead of having it say fill, at the beginning of our function, we say, hey, we want to use that global variable color that we just defined, and when the key B is pressed, we want to change that to be 0, and that should work completely fine. It will work well with grayscale just because we are only having the single number going into it. There is a way if we wanted to specify RBG and use global variables as well. What we can do is actually use this thing called the color command, spelled the American way, and you can either specify a gray value or RGB, so you could also do, which you'll see in some other examples, and that will just pass that in as a color to the function, and it will work as well. So either or will work perfectly fine. I can leave them actually both as is, and I think it will work as well. So we can draw our circles, and as soon as we press B, the circle changes to black. Now, it does not specify in this question is if the next circle should be white. That might be a functionality that we want to enable. So one thing we could do up here is, how would we want to do that? Let me think about this. Is when we have our mouse clicked here is when we would want to. So when we're drawing or specifying where a new circle should be drawn, we could also reset the color. So if we did global color to be the original shade of white. And we just do that by, again, same as we did before. And that could use the color command for 255, or if it's grayscale, you can just pass in the individual value. Now if we run this, I can click, I get my white. If I press B, it turns black. If I click somewhere else, it's white. If I press T, it does nothing. If I press 0, it does nothing. If I press cap locks, it does nothing. If I press B, it changes black. Interestingly, let's try something else. If it's cap locks and B, it doesn't turn black. And the reason for that is because in this key pressed function, it's only checking for lowercase b. And that's completely fine because that's all we asked for in the exercise specification. That was a lot of talking. Some of that might be kind of confusing. It's a lot to kind of wrap your head around, a different way of thinking about our programs than we have been so far in this class. So we're going to try lots of different examples using that model view controller setup. So again, the model will be any variables that would be global. These will be things that the computer needs to remember in order to make changes later on based on user behavior. Our draw function is our view, so that's when we're actually displaying things to our canvas. And then things like our mouse clicked and our key pressed functions, those are our controllers. So those are things that are changing the values of our model, or those global variables, all right? Kind of confusing. You'll get lots of practice though, and it will help to kind of solidify all of those different things. All right, taking a little bit of a break from that, we're going to start talking about all these different Python expressions. There's a couple that I'll highlight, but then the rest I'll have you do on your own. And one thing you can do if you want to convince yourself that that is truly how it works, you can just wrap the expression, oh, I still have my caps lock on, in a print statement. So if you wanted to know what the value of 3 plus 2 was according to Python, you just put print 3 plus 2 exactly as you see it on the slide. You run it, and it will show up here in the console. So that will be 5. And you can do that for any of these at all. A lot of these are kind of your arithmetic operators. So things like plus, things like divide. You also have a whole bunch of other arithmetic operators that we go over in the textbook. One that you might be a little less familiar with is this percent sign. That's called modulo. It's actually a very useful operator in computer science, especially when we're doing things like trying to determine if a number is even or odd. What modulo does is it tells you if you divided the two operands or the two numbers on either side of that modulo symbol, percent symbol, would there be a remainder? If there is a remainder, it will return the number. If there isn't, it would return 0. So for instance, if we say print 4 modulo 2, this should say 0 because 4 is divisible by 2, right? That would be, if you did 4 divided by 2, a value of 2 with no decimal places. If we run that, we do see that it's 0. If instead we did 3 divided by 2, we do have a remainder when we do 3 divided by 2 because it's not just going to give us a whole number at the back. And instead we do get a remainder of 1. So it's going to tell us that, we're going to have some numbers left over here if you try to divide 3 by 2. We have a whole 1 that would make that make sense. If we do other things like 7 divided by 2 and we run that, we get 1 again. And you'll notice if I keep trying these with different even and odd numbers and dividing by 2, we'll either get 0 or we'll get some number that's not 0. And we can use that as a trick in our programs to determine if a number is even or odd. And you'll see that a lot if you continue in computer science. So if you wanted to figure out what would these ones be here, so what would be 11 modulo 5, we can just print that to the console and it will tell us 1. What is 12 modulo 3? Any ideas? Think, is 12 divisible by 3? Yes, it is. So that's a bit of a trickier operator. It will take some time to wrap your head around, but it is one that you'll see quite often. There's a couple tricky examples in here where we're adding floats to integers, so make sure you know what happens when you mix integers and floats. We go over it in the textbook. And then at the bottom here is a really fun one. So we kind of briefly talked about this in one of our previous videos. But when we have strings, we can use things like our plus symbols and our multiplication symbol and do operators on those strings as well. So in this case here, what this is saying is, okay, we have a C string, an O string, and then a key string. And we're going to be doing something that's going to combine all these things together. So just like with mathematical functions, we use order of operations, right? So we'll start with the multiplication, then we'll add the resultant of that expression to the C and to the KIE. Any ideas what that might be? Could it be a cookie? Hint, hint, hint. And you can try out, and I think the best way to try these things out and to get better at the expressions with Python is to just use these print commands, try putting different things into processing, see what you get out at the end. So see if we did just the C plus O, that concatenates or combines those two things together into one string. If we add the times 6, and then we run this, you see we get 6 O's because multiplication comes before addition, added to that C. And finally, if we add in the last little string here, KIE, and run that, we get kooky. I know I kind of spoiled that one, but I just couldn't help myself at the beginning. It's too funny to me. All right. So similarly to what we were doing here, we were taking expressions and trying to figure out what the values were. In this exercise, we want you to take mathematical representations and make Python expressions for them. So this mod is the percent symbol, modulo symbol. You can see examples of all of these, or all of the solutions for all of these in the exercise solutions. And make sure you're using brackets. Make sure you're using your order of operations, which brackets, exponents, division and multiplication, and then addition and subtraction from right to left, right? If you're having problems with any of these, stop by help hours. We would be more than happy to help work through a couple of those things with you, okay? Now that we've had a little bit of a break from, where am I? From thinking about our model view controller design, we're going to do another example of that. I'm going to do this exercise, and then the remaining exercises you'll do on your own. And if you have problems with them, you'll come to help hours or tutorials and we'll give you a hand, okay? So this one here, we're going to be taking a processing canvas, pretending that it's a map of a city and that each pixel is a plot of land. When we click on the canvas, we're going to display the price and the property tax of that land. So we're going to calculate price as a combination of the mouse x coordinate and the mouse y coordinate, and then the tax would be 14% of that price. So if we're going to do this, we need to start thinking, okay, model view controller. So what are going to be our global variables that we need to keep track of? We're going to have our setup function, so that the computer knows we want to make an interactive program. I'm just going to, in our setup, put our size as 300 by 300. We're going to have our draw function. And then we also are going to have a mouse clicked function, if I remember correctly from the description there. Ooh, typing. So we know we're going to have all three of these. What do we actually need to keep track of? We'll have our mouse X, we'll have our mouse Y. We need to display text, so that's going to be in our draw function. And we'll need to calculate tax as well. Maybe we need to keep track of price as a global variable to start off with. Tax we might be able to just calculate right inside of our draw function. I don't think we'll need that inside of our mouse X function, right? Or mouse clicked function. So first, I'm just going to put a return in mouse click so that it doesn't yell at me as I try to build up my program and try different solutions as I go. We were going to keep track here of our price. And originally we'll set our price to be 0. And for our draw, we know we're going to want to have a background color so that it kind of clears every single time. Set that to any grayscale that you want. We know we're also going to want to use our global price command that we have, or variable, that we have. And inside of our draw, we're going to want to display the price of the land. So let's just put out a text command. We can add a string that gives some clarity to what we're actually doing here. What is this value that we're displaying? And then we can give it the position of where we want that to be in terms of X and Y coordinates on the canvas. So let's just give it a starting of X of 10 and Y of 50. Now, if I just run this, all we should see here is land price. You know what I'm going to do? I'm going to change my background to black so I can see that white text a little better. Stop it, exit that out, and run again. Oh, and I made it white. Oh my goodness, y'all were probably just yelling at me the whole time. Kim, Prof. Kim, you did that wrong. There we go. We made it black. Beautiful. So we just have land price. We're not displaying this value yet. So next thing we're going to do in our draw function here is get that variable value to actually show up. So again, a second text command. And instead of passing in a string as our first argument, let's just use our variable there. That's going to tell the computer, okay, when you're running, go look at that global variable and just put whatever value we have in there as the text that we want to display. Let's put it at the same X value and just move it over slightly so that it kind of lines up with hopefully where we want it to see. Just after that colon there. We'll see. We might have to do some fiddling with those numbers there. Ah, no, what did I do? I changed the Y, not the X, and that's okay. If I wanted to move this over ever so slightly so that it was at the same, what I was talking about, we leave the Y the same. This is why we should have drawn this out first. And we'll move the X over. Let's see if that works. There, so you can see the land price right there. And we might have to move that over slightly, but that's okay. Okay, so we got that going. Not going to worry too much about the property tax just yet. I want to be able to change my price whenever I click my mouse. So if I do this right now and I start clicking around, whoa, I'm clicking out of things, it doesn't change my price as I don't have anything defined in mouse click. So what I'm going to do is say, okay, in mouse clicked, bring me that global price variable we have. And what I want to do is update it. So in order to update it, all I'm going to do is say the variable name price, then that assignment symbol, which is the equal symbol. And as we said, the price was going to be the X and the Y value combined for mouse X plus mouse Y. So when we're assigning variables, they don't just have to be a single value. We can assign them expressions, and what would happen when the program is running is the computer will figure out what's the value of that expression and assign it back into price. So if we do that, and if I run this again, and now I click, look at that! We get different values for our land depending on where we're clicking on this canvas. So that's working great. The only thing we have left to do in this is add in the tax. So in our draw, we need to add in 2 more text commands. One is going to be property tax. So I'm just going to put in a string that says property tax. And we'll place that at the same X and just a little further down. And then we want to use the text. And we're going to say, okay, instead of it just being a variable here, we can either directly put this in, price times 0.14, which is how you would get 14%. That's just the math behind it. And then we'll place it at the position we want to be. So again, we'll do about 80 over and same Y value. I'll show you a couple of different ways we can do this after, once we make sure this is working properly. So property tax starts out at 0.000. And as we click around, it's successfully updating. We can do some math with our calculators to make sure it's doing the right value, but I trust myself that I know what this is. Another way we could do this is we could actually define a local variable inside of our draw function called tax. And what we would do is assign it the value of this exact same expression we used in the text. And that's just saying, okay, for this next part here, I want another variable that's going to store the value of the tax based on my price and then multiplying it by 0.14 so that we get 14% of the price. Then in our text command, we can just use that variable instead of that expression. Both are equally valid options. Both will give the same behavior when you're clicking around and running your program. Either is fine for this class. It really comes down to preference. When you're creating variables, you're adding in a little bit of extra documentation to your program. So if you ever went back, it's a little bit easier to understand what you were doing there, but either or will work. If you take a look at the assignment solution as well, they don't use a global variable for price. They use global variables for X and Y. That's okay as well. You can take different approaches to your model, and as long as you're following that model view controller design, you can get the same output out of the end, okay? So if you wrote up your own solution and you're like, hey, it's kind of different than what you presented here, Cam, and what's on the solution, and I'm not really sure if this is right, stop by Help Hours. I'd be happy to take a look, all right? Okay. So for exercise 6, you're going to work through this following program behavior. So thinking about what kind of information the computer would need to keep track of as a global variable, so in its model, in order to do this. You'll have a single circle that gets placed wherever the user clicks the mouse. That's really similar to an exercise we just did in this video. If we press R, it's going to turn to a red color. If we press G, it's going to turn to a green color. And then if we press B, the background will turn black. And if we press W, the background will turn white. So it's almost like that program we just built up a couple exercises ago, but just a few more options than what we had before. So think about what additional information would need to be stored in the model, if any. And then think about what would we use in the display function, what would we use in the key pressed or mouse clicked functions to update the model. How would all of those different things work? You can write some notes down, you can think about it, get a really good idea in your head before you go into actually typing and processing. And then for exercise 7, what I want you to do is actually make that program. So take what you think should be the model, take what you think should be in the draw function or in the view, and take what you think should be done for the controllers and build up that program. It's going to be very similar to the one that we did a little while ago. It's like, 2-3 exercises ago. And you can check the solution code that's in the exercise solutions to see if it's similar. It might not be identical, and that's okay. If you have questions about whether it's correct enough or whatever, just let me know, all right? And then at the end here, I'll give you this one as an extra one to study with. So you're keeping track of the total number of times the key is pressed and then using text to display that onto the canvas. So we're not using print, we're not displaying to the console, we're displaying to the canvas just like we did with that land price and property tax example. And anytime any key is pressed, you'll increase that counter. So you can start thinking about, okay, what information do I need to keep track of so that when I'm redrawing 60 times a second, I'm getting the correct information on there. And in the mouse clicked function, what things will I be updating? And see if you can get it to generate a solution that looks something like that at the end, all right? Good luck. Happy coding.